Hey guys, today we're going to be talking about section 1.4, which is arithmetic sequences and series. And the notes are going to be on page 25 in your workbook. And then if you notice on that page 25, I've marked out like the activity questions because we're going to use that space for notes because there are 3 definitions and a couple formulas that you're going to want to have space for. So we're going to do that right here. So let's talk about an arithmetic sequence. And yes, I am saying arithmetic because that's how you pronounce it. It looks like arithmetic, but when we're talking about the sequence, we say arithmetic. So an arithmetic sequence is a set of terms that are formed by adding a common difference. So you see that table above, and an example of an arithmetic sequence would be something like 1, 5, 9, 13, 17, and so on. And so what makes this sequence arithmetic is that we are adding a common difference. So like from 1 to 5, we're adding 4. From 5 to 9, adding 4. From 9 to 13, adding 4, and so on. So the common difference from this sequence is 4. So I'm going to say D equals 4. Now, the common difference could be positive, but it could also be negative. So if I had a sequence like 15, 10, 5, 0, you'll see that instead of adding the same number, this time we are subtracting. So I'm subtracting 5 every time. So for this sequence, the common difference, abbreviated D, would be negative 5. So common differences can be positive or negative. And if you're wondering why are we doing this when we're talking about functions and graphs and increasing and decreasing intervals, well, arithmetic sequences are linear. So they're a linear function, and this entire chapter is all about linear functions. And linear functions happen whenever you add a common difference. So you can think of that common difference as being the slope of the sequence. So slope is kind of like the common difference. Okay, another thing you'll need to know before we start doing a couple examples, there are 2 formulas for how you can get the terms in an arithmetic sequence. So our first formula is called the recursive definition or the recursive formula. And it looks like this. It's a piecewise function where we have a sub n equals a, and this 1 right here is a subscript. So a sub 1, comma, n equals 1. The way we'd read this out loud is a sub 1 if n is equal to 1. Now, what does n stand for? N is the number of the term. So let me grab a different color here. The sequence up here, that's 1, 5, 9, 13, 17. Those are the terms, but I can also number the terms. So the n would be my first term, 1 would be the first term. So that n value would be 1. The second term is 5. So n is 2 for 5. My third term is 9. So n would be 3 for 9. My fourth term is 13. So n is the number of the term. So what this first line is saying is if it's the first term, then you get a sub 1. And a sub 1 is the first term, which kind of sounds like, huh? If it's the first term, then it's the first term. Yes, that's exactly what it's saying. Then we have the second line that says a sub n minus 1. So we need to know what a sub n minus 1 is. A sub n minus 1 means the previous term. And D stands for the common difference. So a sub n minus 1 means you take the previous term, and then plus D, you'll add the common difference. So what this is saying, the recursive definition says, okay, you've got your first term, that's that first line, but if it's anything after the first term, you take the previous term and you add the common difference. So let's go ahead and do an example before we come back and take a few more notes. So flip the page, go to example 1A, and we have to figure out, is this sequence arithmetic? And if so, what's the recursive definition? Okay, well, for part A, I look at these terms 25, 20, 15, and 10, and I notice, okay, they are subtracting 5 from the first two terms and then subtracting 5 again, subtracting 5 again. Okay, well, it looks like the common difference is 5. So that, since that's constant, we'll say yes, this is arithmetic. So then it says, what's the recursive definition? So here's what the recursive definition would look like. A sub n means any term I want is equal to the first term, which is 25, if n equals 1. So that line is saying if I want the first term, it's 25. Cool. The second line is going to say if you want any term after the first term, you're going to take the previous term, a sub n minus 1, and add my common difference. And my common difference is negative 5. But plus negative 5, let's go ahead and simplify that to just minus 5. And so that is the recursive definition. Now, it does also say what's the next term in the sequence. I can find that by subtracting 5 again and get 5. Now, I do want to say that this notation that's boxed in, this is how you would see it printed out in a book of the recursive definition. It's set up as a piecewise function. But when you go to do your problems in Math Excel on Savos, then you'll notice that they don't have the piecewise syntax in there. It doesn't look that great. So what you'll see in Savos for this one, in Savos, they'll ask you for the recursive definition, but they'll want you to type in like a sub 1 equals, and you would just say 25. And then they have a line like, okay, then what's a sub n? And then you would type a sub n minus 1 minus 5. So that's how they would have you enter your answer in Savos, just so you know. So that's the recursive definition. It's nice, but you need to know the previous term. Okay, now let's go and take a couple more notes. So go back to what page was this? Page 25. And the recursive definition is nice because what it says is that if you know the previous term, you can get the next term by adding the common difference. Cool. But we don't always know the previous term. Sometimes I have a list of numbers and then I'll say, okay, now what's the 99th term? So there's kind of a need for a different formula or different definition. So there's also something called the explicit formula or the explicit definition. And there are no bad words in this formula. Haha, it's explicit, right? Explicit formula. But yeah, there's no bad words in it. So we can do it in school. Okay, so then the explicit formula will look like this. A sub n equals a sub 1. And when I say sub, I mean subscript. Plus d times n minus 1. And what the explicit formula does is it allows you to find any term in a sequence without having to know the previous term. Any term. And so you'll notice some variables in here. A sub 1, again, is the first term. D is still the common difference, and N is still the number of the term. So all these letters still represent the same thing. Okay, so let's go back and do a couple more examples. Example 2, translate between recursive and explicit forms. So part 2a says, for the recursive definition, a sub n equals 45 if n equals 1, and a sub n minus 1 minus 2 if n is greater than 1. What is the explicit definition? Okay, so I'm going to come over here and remind myself that the explicit definition is a sub 1 plus the common difference times n minus 1. Okay, so then I'm going to write a formula for that. So a sub n equals, and when you write the formula for the explicit definition, all you have to do is substitute a number in for the first term and for the common difference and simplify. Everything else you leave alone when you're asked for the formula for it. Okay, so my first term, I can pull from the recursive definition right there. It's 45. Because in the recursive definition, that's where we always find the first term. Plus, now I have to look and see what the common difference is. Well, the common difference in the recursive definition is right there. So instead of plus 45 plus, I'll do 45 minus 2 times n minus 1. So that's the explicit definition. But we're going to need to simplify our answer so you can distribute this negative 2. So a sub n equals 45 minus 2n plus 2. But then that will simplify even further. So we have a sub n equals 47 minus 2n. Then example B has us go the other way. They give us the explicit definition, and then they ask for the recursive. So whenever I'm doing, let me remind myself of the recursive definition. A sub n equals a1 if n equals 1, and then a sub n minus 1 plus the common difference if n is greater than 1. And when you're filling numbers into the recursive definition, you'll need to fill in a number for a sub 1 and for the common difference. Everything else will stay the same as the general formula. So for this example, when I write the definition, I'll say a sub n equals my first term. Well, since it's an explicit form, that's the place where we find the first term. So 1 if n equals 1. And then the second line, a sub n minus 1 plus the common difference, which we'll find right there, plus 7 if n is greater than 1.